Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to continue our discussion on inequalities, but we're going to talk about some different types of inequalities, specifically compound. So in our last video, we just talked about single inequalities. Today we're going to be talking about two inequalities, and there's a couple different types we can have, but we'll get into that shortly. First thing I want you to do, just like last video, is can you turn these inequalities into words? So you can either write these in words, or if you want to, you can also write these algebraically, so in symbols, numbers, and letters. So look at the graphs, think about what types of inequalities these are, how you would express them in some other form, and see if you're able to do that. Then come back and see if your solutions match the ones that we're looking for. All right, so for number one, two inequalities we could write. We could say x is less than 5. Okay, that describes this inequality right here. But then we have this other one, and we're going to use an or x is greater than 7. So the solutions that we're graphing, they're either numbers that are less than 5 or they're greater than 7. And if we wanted to write that in words, I'm just going to type it. We could say x is less than 5 or x is greater than 7. All right, for number two, it looks a little different. So this time the arrows aren't going off to the left and the right. We have a specific set here, the numbers between 2 and 4. So the way we write this is we say x is greater than or equal to 2 and x is less than or equal to 4. So it's not either or, right? There are numbers that are greater than or equal to 2, like 5, that aren't part of this solution set, right? So we have to say and. The number has to be greater than or equal to 2, and it has to be less than or equal to 4. So if we were going to type that or write that out, we would say x is greater than 2 and less than or equal to 4. And I just realized I made a small mistake. X is greater than or equal to 2 and less than or equal to 4. Okay, so this is kind of a little bit of an introduction to what compound inequalities are. Compound inequalities are when we have two or more inequalities. Today it's just going to be two because we're talking about just a single number line. So let's dive into more specifically what these are and how we solve them and graph them. So compound inequalities are made up of two or more inequalities. The and compound inequalities are where each solution is restricted by both inequalities. So you have to pay attention to both inequalities to think about what your solutions are. For the or compound inequalities, this is when each solution is part of one of the inequalities or a part of the other, but it cannot be a part of both. So let's look down here and we'll kind of discuss what exactly those words are talking about. So for the first one, and you could always pause the video and see if you could write out what these inequalities are. We're going to use algebraic expressions. I'm not going to type these in words, so that's the form we're going to use. So I would say x is less than or equal to -2, or x is greater than 5. Now again, this is an or inequality because the solutions here, right, if a number is less than or equal to -2, it cannot be greater than 5, right? If you pick a number down here, if we just continue this, if we picked a number -5, right, -5 cannot be greater than 5. That's just a false statement, right? Same thing if I picked a number up here like 6, right? Well, 6 is not less than or equal to negative 2, right? This is also false. So when you have or inequalities, that is when your solutions can only be a part of one of the inequalities, right? A number can either be less than or equal to negative 2, or it's going to be greater than 5. But no number is going to fit both of these. No number is less than or equal to negative 2 and greater than 5. So if you're unsure of whether it's an and or, test one of your points, right, that the inequality says is a solution, and see if it works for just one of them or for both of them. If it just works for one, it's going to be an or inequality. If it works for both, it's going to be an and. Okay, let's look at the second one. So here we have x is greater than or equal to negative 2, and x is less than 5. Again, we have an open point here, so we're going to use just a less than sign, not a less than or equal to. Now let's pick a point somewhere here. Let's pick the point 0. We know that that is a solution because that is one of the points that's graphed. Now, does 0 fit both of these inequalities or just one of them? Well, let's test. 0 is greater than or equal to negative 2. Well, that's true, right? 0 is greater than or equal to negative 2. And is 0 less than 5? Well, this one's true as well. This is what makes this an and inequality, because our solutions work for both. Whereas for our inequality over here to the left, if we picked a point like negative 5, right, negative 5 only worked for this inequality. It was less than or equal to negative 2, but it was not greater than 5. This was no good, so that's why it made it an or inequality. All right? All right, let's move on. We are now going to do some practice with, again, we're going to solve these, and then we're going to go ahead and graph them. So if you feel like you're comfortable, go ahead, pause the video, work through this first one, then come back and look at the solution, and then you can just keep going. So I would always try these problems on your own and then come back and see how you're doing, and that'll give you some confidence to keep going on your own or keep watching the video for some extra help. Okay, so for all of these inequalities, when you have 2, you're going to solve them individually and then graph them individually as well. So I'm going to subtract 4 from both sides here. That's going to give me 7x is less than 14, divide by 7, and I get x is less than 2. So that's one of them. Then I'm going to come over here and solve. I'm going to subtract 3x from both sides. So I'm going to get x is greater than or equal to 5, and I'm done, right? There's nothing else for me to do. So let's now graph these. And actually, let me put these in 2 colors. So, oops. Just so our graph stands out more. So we have x is greater than or equal to 5. So let's graph the brown one first. We know that this is an or inequality. So we have x is less than 2. And because it's a less than, it's going to be an open point, and it's going to go this way because these are the numbers less than 2. Then we have x is greater than or equal to 5. Because it's greater than or equal to, I have a closed point, and I'm going to draw it in the direction of numbers that are greater than 5. So this would be my graph. For an or inequality, and again, you're going to start to pick up on some patterns here, right? The or inequalities are starting to look kind of the same, right? The direction of the arrows are going in opposite directions of one another. For the ones that we've done at least, right? So one is going all the way towards the negative numbers, the other one is going all the way towards the positive numbers. There are some special cases where they could be going the same direction. However, for the majority of the time, they're going to be going in different directions. All right, so we're done with this one. Let's move on to another one. All right, so this one looks a little different, right? There's no word. It doesn't tell us whether it's an or whether it's an and inequality. However, the way they wrote it does. So whenever you see an inequality that's written together, and it looks like there's two of them. This is going to be an and inequality, and you can split it up like this. I'm going to move the negative 7 is less than or equal to 9x plus 20 over here. That's one of your inequalities. And the other one is going to be 9x plus 20 is less than 2. So that's my other one. This is an and. And that's because this quantity right here is greater than or equal to negative 7, and it's less than 2. Right? It's the same thing. It's greater than or equal to something, and it's also less than something else. So let's go ahead and solve. Solve the red one first. I'm going to subtract 20 from both sides. So I get negative 27 is less than or equal to 9x. Or you could say 9x is greater than or equal to negative 27. I'm going to divide by 9. And I'm going to get, I'm going to read this the other way. So x is greater than or equal to negative 3. Okay, let's solve the other one before we graph. I'm going to subtract 20 from both sides again. So this is going to give me 9x is less than negative 18 divided by 9, and I get x is less than negative 2. So let's start by graphing the red one. I have x is greater than or equal to negative 3. So closed point, and I'm looking for numbers that are greater than negative 3, so I'm going this way. Then I'm going to graph my my blue one, which is x is less than negative 2. So I'm going to start at negative 2 with an open point because it's just less than. I'm going to go the other way. Now here's the thing. This is an and inequality. And with and inequalities, we know that the solutions have to work for both inequalities. Right? I can't pick a solution and just have it work for one. It has to work for both. So take 30 seconds to pause the video. Think about which part of this number line is going to work for both the red and the blue inequalities. All right, well, let's just test a couple of numbers. I'm going to test 0 first. So if I pick the point 0, let's test it for the red. I get oops, I need to draw it on the other side. So I get negative 3 is less than or equal to 0. Okay, that checks out. And over here I get 0 is less than negative 2. Well, that doesn't check out, right? Because 0 is greater than negative 2. So that's false. So I can't include 0. And I also can't include any of, well, actually, we'll hold on to say that until the end. Let's test another point. Let's test one over here. We'll test negative 6. Let's test it for the red. So I get, and you can read this whichever way you want, negative 3 is less than or equal to negative 6. This is false. Right? Negative 3 is greater than negative 6. And if I test it over here, I get negative 6 is less than negative 2. Well, that works, right? That is true. And that makes sense because this brown point was on the blue inequality, right? So it should work for the blue one, just like the pink was on the red one, so it should work for the red. I need points that work for both, though, right? So those points, and maybe you've already figured it out, those points are going to be found between these 2 points. They're going to be found where the inequalities overlap, right? So we have to shorten our solution set. And I'm going to have to erase some stuff here. The only solution set that we have is right here, because that's where the overlap is. So our solution set is actually much tinier than it looked like it was. It only includes numbers from negative 3 to negative 2. We can include negative 3. We cannot include negative 2 based on our open versus closed points. So for and inequalities, you're going to be looking for the overlap when you graph. For the or inequalities, well, there's not going to be any overlap, right? So you're not looking for it. But when you have an and inequality, you have to look for that overlap. If there's no overlap, then there's no solutions, because for and inequalities, the solutions have to work for both. All right, so down here, we're just summing up what we said. Remember, for and compound inequalities, all your solutions must be a part of both solution sets. Thus, you can only include the overlapping solutions in your final set. That's why we had to narrow our solutions down to this set, because that was the only overlapping portion of those red and blue inequalities. All right, let's maybe do one more, and we may have to call it. All right, let's come down here and do a tougher one. Let's do another and inequality. All right, so again, we're going to be looking for that overlapping portion here. Maybe we'll go back and do one or inequality as well if we have time, just so we get 2 and 2 of both. First thing to do is to rewrite your inequalities so that you have 2 single ones. So I get x minus 5 is less than 2x minus 6, that quantity divided by 4. And then I'll have 2x minus 6 all over 4 is less than or equal to x. So we have variables on both sides, but again, we've solved equations like this, so we can certainly solve inequalities. Let's solve the red one first. I'm going to add I'm going to multiply both sides by 4. Don't want to add. So I get, distribute over here, I get 4x minus 20 is less than 2x minus 6. Subtract 2x from both sides. So I get 2x minus 20 is less than negative 6. And then I'm going to add 20 to both sides. That's going to give me 2x is less than 14. I'm going to divide by 2. And I'm going to get x is less than 7. So it took a little longer, but nothing we can't handle. Let's go ahead and solve blue. I'm going to multiply both sides by 4. So I get 2x minus 6 is less than or equal to 4x. Subtract 2x from both sides. I get negative 6 is less than or equal to 2x. Divide both sides by 2. And I'm going to read it starting with my x. So I can say x is greater than or equal to negative 3. So let's graph the red one first. I have x is less than 7. Open dot because it's no equals sign. And less than has me going this way. Now if I do my blue, I've got x is greater than or equal to negative 3. So close dot. I need to go to the side that has numbers greater than negative 3. So I'm going this way. Okay, so because this is an and inequality, I'm looking for my overlap. And my overlap is from negative 3, close dot, all the way to 7 with an open dot. This black is my solution set. Okay, because that is the overlap between the red and the blue. If you did not have the black, or if you did not erase the extra red and the blue that were going outside of that section from negative 3 to 7, you would be marked incorrect, or you'd lose some points. Okay, one more. We'll do another or inequality just so you get another chance at that as well. We'll do the one right above it. It's nice because or inequalities are usually already separated for us, so we just have to go ahead and solve. I'm going to add 2 to both sides. So I'm going to get negative 8 is greater than 2x. Divide by 2. And I get x is less than negative 4. So that's one of my solutions. The other one is a little easier, just a one step. And I'm going to read it starting with my variable. X is greater than or equal to 2. I know this is an OR inequality, so I don't have to worry about any overlap. I just graph both of them, and that's my solution. So I have x is less than -4. So open point, and I look for the numbers less than -4. Again, this is an example where the arrow is going the opposite way of the inequality sign. That's okay, because we have to think about, again, we have to think about how this inequality is read. It says x is less than -4. So we have to choose numbers that are less than -4. That means we're going to the left. For the blue, we have x is greater than or equal to 2, so closed point, and we look for the numbers greater than 2, which is going this way. Again, it's an OR inequality, so we don't have to worry about the overlap. The solutions don't have to work for both inequalities. They just have to work for one or the other. All right, so we're done with this problem, and while I thought we were going to be done with the video after this one, there is another page of this packet, and I'd like to do at least one or two of those examples so you're aware of how you do those problems on the last page. So we're going to go there, and then we will wrap up the video. All right, so we have 4 problems here, and we're actually just going to quickly go through all of them. I would encourage you to pause the video, attempt to come up with the algebraic representation of these inequalities. They can either be a single inequality or they could be a compound. So they could be a single, an and inequality, an and compound inequality, or compound inequality. So pause the video, take some time, then come back and check your solutions. Okay, so the first one we have x is greater than or equal to -3. We have to include the or equals to part because it is a closed point, and the numbers that the blue arrow is above are greater than -3. For number 2, we actually have a compound inequality, and this one is an and. We start off with x is greater than -7, and x must be less than or equal to 3. Okay, that's what that graph shows us. Another way you could write this, you could combine them. You could say, and I'll do this up above here, -7 and 3 on the outsides. You have x is greater than -7, and it's less than or equal to 3. So this is okay, or this is okay. They're both two ways of showing that we have an and compound inequality. Number 3 is an or compound inequality. So we have x is less than or equal to -5, close point. So that's less than or equal to. Or x is greater than or equal to 0. Just one way to write that. You need to include the words or between those. Okay, let's look at the very last one. This is another and compound inequality. So again, we could write this two ways. We have x is greater than or equal to 0, but x is also less than 6. So that's the way to write it together, or you could write it separately. X is greater than or equal to 0, and, oops, let's fix that. Fix that 0 too. X is greater than or equal to 0, and x is less than 6. So both of these perfectly acceptable ways of writing the compound inequality for number 4. Okay, now we are officially done with this video. I look forward to seeing you next time. We are going to start some inequality word problems, so we have those to look forward to. All right, as always, enjoy the rest of your day, and I'll see you next video.